Hello students, in this video we will learn rates of change. In this concept we are going to learn mainly 3 points. First one is the rates of change. What is the rates of change? And some examples. What is average rate of change? And what is instant rate of change or instantaneous, instant or instantaneous rate of change. Let's get started. Here rate of change means finding the slopes or process of finding slopes. So rate of change, the another name for rate of change is finding the slope or process of finding slope. Here by the definition, the rate of change is the amount of change in one term or in one quantity is divided by the corresponding amount of change in the other. This is known as rate of change definition. Here, second point, the rate of change formula gives how one quantity changes in relation to change in the other quantity. This is the overall idea on rates of change. So you remember one thing, rate of change means is the process of finding slopes. Here we have some formulas on rates of change, a basic formula and rate of change of formula in algebra, and last one is rates of change of functions. Here starting with the first formula, here rate of change is the formula rate of change is equal to, formula for this is basic formula, change in one quantity or change in quantity 1 divides change in another quantity, that is quantity 2. Okay, so this first formula is basically known as, this is the basic formula. Basic formula. And now coming to second formula for rate of change. Rate of change is equal to generally it is also written as delta y by delta x. What is the Greek letter delta represents? Here the Greek letter delta represents the change in quantity. So delta y means change in y, delta x means change in x, is equal to, all of you know about this formula, y2 minus y1 by x2 minus x1. So this second formula is known as a rate of change in algebra. This is the formula of rate of change in algebra. Algebra means if 2 points are given, then we usually find the slope. So difference in y coordinates by difference in x coordinates. Okay. So this is known as, this is represented as delta y by delta x. Delta y means change in y quantity divides change in x quantity. Okay, coming to the next formula here, third formula, rate of change f of b minus f of a by b minus a. So this is the formula for rate of change This formula can be used when rate of change of a function, rate of change of a function. Yes, so we have three formulas for finding the rate of change. First formula is basic formula. Rate of change is equal to change in quantity 1 by change in quantity 2, or change in the first quantity by change in the second quantity. Second formula is rate of change delta y by delta x is equal to, if 2 points are given, delta y means change in y quantity by delta x means change in x quantity, that is equal to y2 minus y1 is x2 minus x1. So this formula is also known as rate of change in algebra. And last formula, third formula, f of b minus f of a by b minus a is equal to rate of change is the formula. It can be used for a rate of change of a function. Okay, so a rate of change tells us how something changes over the time. Okay, now coming to some examples. Using the rate of change formula, calculate the rate of change for the following information. Here the information is given: time during in hours, distance traveled in miles. Here for 2 hours the distance traveled by a car or any vehicle 40 miles. For 4 hours it can be traveled 180 miles. Now we are going to find a rate of change for this information. Next, here to find the rate of change we use basic formula here. All of you know basic formula here. So solution, a rate of change. Yes, rate of change is equal to, what is the basic formula? Yes, change in quantity 1 or first quantity by change in the second quantity or quantity 2. Okay, here what are the quantities? Here is change in the first quantity, means here we are going to find a change in the distance. That's why change in the first quantity is considered as distance, that is change in distance by change in second quantity as time. So change in time. Here change in distance, what is the information on distance is given in this problem? 40 miles, 180 miles. So change in distance means 180 minus 40. So here 180 minus 40, that is change in distance by change in time, means here the time information 2, 4. So change in time means 4 minus 2. So 180 minus 40 means clearly 140 by 4 minus 2 means here 2, that is equal to 70. So what is a 70? Is it a time or it is in the distance? Yes, clearly it is in distance. What is the first quantity in this formula? That only represents the answer. ఇక్కడ మనం తీసుకున్న ఫార్ములాలో ఫస్ట్ క్వాంటిటీని మనం డిస్టెన్స్గా మనం కన్సిడర్ చేసుకున్నాం కాబట్టి మనకు వచ్చే ఆన్సర్ కూడా ఫస్ట్ క్వాంటిటీని మనం ఏదైతే చూస్ చేసుకున్నామో దాని గురించే వస్తుంది. కాబట్టి ఈ 70 అనేది టైం కాదమ్మా, దిస్ ఈజ్ డిస్టెన్స్. డిస్టెన్స్ దేంతో ఇచ్చాడు ఇక్కడ? మైల్స్. సో మైల్స్. సో we conclude that the rate of change of distance the rate of change of distance with the time is 70 miles per hour. 70 miles per hour. This is the first example. Now coming to second example. Calculate the rate of change for the following information in table. Here the information is time in days and height of the tree in inches. So for 50 days it grows 4 inches. For 140 days it grows, means a tree grows 7 inches. Now we are going to find the rate of change of height of the tree. So coming to solution here. Rate of change, basic formula. Rate of change. What is rate of change basic formula? Yes, change in quantity 1 by change in quantity 2. So change in quantity 1 can be assumed as quantity 1 as height of the tree. Quantity 2 is time in days. So change in quantity 1 is change in height of the tree by change in second quantity, change in time. So change in height of the tree is, what is that? Yes, 4, 7. That's why 7 minus 4 by change in time is 140, 50, 140. Means here 140 minus 50. So that is equal to, clearly this is 7 minus 4 means 3 by 140 minus 50, that is 90. This is also equal to 1 by 30, that is equal to 0.03 and so on. So what 0.033 represents? The rate of change of height of the tree with the time in days is 0.033 inches per days. Okay, here we conclude that therefore the rate of change of height of the tree with the time in days is 0.33 inches per days. Okay. Now coming to next definition, average rate of change. What is average rate of change? Average rate of change is the slope of the 2 points. Already we discussed in the previous, the rate of change formula in algebra is, what is that? Yes, y2 minus y1 by x2 minus x1. This can be considered as average rate of change, or slope of the secant line is called average rate of change. What is secant line? Here, to much understand, we have a graph here. This is x-axis and this is y-axis. Suppose a given function f of x is equal to x square. So all of you know about the x square graph. Here, yes, this is the graph of the function f of x is equal to x square. On this graph, we have 2 points, or we assume 2 points here of 1, 2, or 3. By joining these 2 points on this curve, we draw a line. Yes, this is the line. So any line joining the 2 points on the given curve is known as secant line. So to find the slope of the secant line, suppose what is the point? Suppose here on the y-axis we have the points 1, 2, 3, 4, 5, 6 and so on. So for this we have the x value is 1 and y value is 2. And for this point also we have the x value as 2 and y value is 5. Okay. So what is the formula for that? Change in y-axis or change in y-coordinate. y2 minus y1 by x2 minus x1 represents the slope of the secant line. So that is equal to, what are y values? 5, 2. So 5 minus 2y, 2 minus 1, that is equal to 3 by 1, that is equal to 3. Here 3 represents the slope of the secant line. It is also known as average rate of change. Okay. Coming to next definition, instantaneous rate of change. What is the instantaneous rate of change? The instantaneous rate of change or instant rate of change is the slope at a single point. Here we want to find the slope for a single point is known as instant or instantaneous rate of change. It is also called, it is the slope of tangent line. So to better understand on this, we have a graph here. We have a graph, suppose here is the graph of the given function f of x is equal to x square. Suppose we take a point on this curve. If we draw a line through the given point like that. So this line is known as, what is that? Yes, very good. It's the tangent line. So a line touches the given curve at one point. That line is called as tangent line. So to find the slope of this tangent line, this is tangent line. To find the slope, the process of finding tangent line is known as instantaneous rate of change. Or why? Because here we are going to find the slope of the tangent line. It is the slope means rate of change finding at only one point, okay, or at one point. This is known as instant or instantaneous rate of change. Okay. Coming to some problems here. Find the average rate of change of the function over the given interval r is equal to root over 4 theta plus 1 on the interval 0, 2. Here we want to find the average rate of change of the function over the interval. Here the formula is, we use the formula solution. The average rate of change of the given function over the given interval, closed interval. So that's why here average rate of change, that is equal to, what is the formula for average rate of change for the function on the given interval is f of b minus f of a by b minus a, or simply it can be written as y2 minus y1 by x2 minus x1 also. చూడమ్మా ఇక్కడ ఫంక్షన్ ఆర్ అనే ఫంక్షన్, ఆ ఆర్ అనే ఫంక్షన్ మేము ఏ విధంగా తీసుకున్నామంటే ఎఫ్ అను, లేకపోతే మీరు కావాలంటే ఆర్ అని కూడా రాసుకోవచ్చు, ఆర్ ఆఫ్ బి మైనస్ ఆర్ ఆఫ్ ఏ. ఇక్కడ ఎక్స్ వాల్యూస్ ఏంటయ్యా అంటే థీటా వాల్యూస్ కదా. సో చేంజ్ ఇప్పుడు ఈ ఫంక్షన్లో మనకి ఇక్కడున్న ఎక్స్ వాల్యూస్ ఆర్ థీటా వాల్యూస్ మనం సబ్స్టిట్యూట్ చేయడం వల్ల వచ్చే వాల్యూ ఏమంటే ఆర్ వాల్యూ. ఆర్ వాల్యూ ఈజ్ నథింగ్ బట్ వై వాల్యూస్. సో అందువల్ల ఇదే ఫార్ములాను y2 మైనస్ y1 బై x2 మైనస్ x1 కూడా రాసుకోవచ్చు. సో ఫ్రమ్ దిస్ ప్రాబ్లమ్ వీ హ్యావ్ ది ఫార్ములా r of b minus r of a by b minus a. Here what is a and what is b? Here a is 0, b is 2. So we plug in the points a, b values in the function r in place of theta. R of b is equal to square root 4 into theta means r of b 4 into 2 plus 1 minus r of a. Here a value is 0. R of a means in place of theta we plug in 0. So 4 into 0 plus 1 by b minus a. B minus a means here 2 minus 0. That is equal to root over 4 into 2 plus 1. That is equal to 8 plus 1, that is 9 minus root 1 by 2. Root 9 value is basically it is 3 minus root 1 is 1 by 2, that is equal to 2 by 2, that is equal to 1. Okay, this is average rate of change of the given function. Therefore average rate of change of the given function is 1. Next, coming to Another problem here. Is coming to second problem. Find the ARC. ARC means here average rate of change of the function over the given interval. F of t is equal to tan t is the given function for the interval, closure interval pi by 4, 3 pi by 4. Here we are going to find average rate of change of the given function. F of t is equal to tan t over the given interval pi by 4, 3 pi by 4. Here we are going to write the formula for the function on the given interval, average rate of change. Average rate of change, ARC, average rate of change is equal to, yes, we know f of b minus f of a by b minus a. So here a is pi by 4, b is 3 pi by 4. So if we plug in t as b, so f of b means tan b, and if we plug in pi by 4 as a in place of t, we have tan a. So right here tan b means here b value is 3 pi by 4 minus tan a, here tan a is, a value is pi by 4, by b minus a means 3 pi by 4 minus pi by 4. That is equal to tan 3 by 4 means here tan, yes, 135 degrees minus tan 45 degrees by 3 pi by 4 minus pi by 4 means here is, so both denominators are equal. 3 pi minus pi means here 2 pi by 4, 2 cancel, here is pi by 2. So tan 135 value, what is tan 135? Tan 135 can be written as here like that. Tan of 180 degrees minus, yes, 45 degrees minus tan, already we have 45 degrees, by pi by 2. So here continues. So tan 180 minus 45 means it is on x-axis. So it is in means it is in second quadrant. In second quadrant, tan value is a negative. That's why here we put a minus negative value. So tan of 180 minus 45 means tan 45 degrees minus, already we have tan 45 degrees by pi by 2. That is equal to minus tan 45 value is 1. So minus 1 minus tan 45 again 1 by pi by 2. So minus 1. So here minus 2 by pi by 2. That is equal to, yes, minus 4 by pi. This is the average rate change of the function f of x, sorry, f of t over the interval pi by 4 comma 3 pi by 4. Coming to next problem. The profits of a small company for each of the first 5 years of its operation are given in the following table. This is the first column of years, second column of profit in thousands. So in 1990 we have the profit 6,000. In 1991 we have 27,000, and In 1992, 62,000. 1993, 11,100 or 11,000. In 1994, it is 174,000. Here, what is the average rate of increase of the profits? Increase of the profits between the year 1990 and 1993. Here we are going to find average rate of change, means average rate of change of profits between the years only from the given table. So observe carefully. So what is the profit of 1990? For 1990, profit in 1990 profit is 6 is equal to 6. So profit in 1993 year. What is the profit in 1993 year is 1,1,000. So from this data we are going to find average rate of increase in profit. Increase in profit is equal to, so is equal to triple one minus 6 by, between the years we have how many years are there between these 2 years? We have only 1991, 1992. So that's why there are 2 years by 2. So that is equal to triple one minus 6 means how much it is? Yes, 105 by 2. That is equal to 105 by 2 means here is 55.5. So therefore, average rate of change of profit between the years 1992-1993 is 55,500. Okay. Next problem. Here the fourth problem. Here we have the important problem here. The accompanying figure shows the plot of distance fallen versus time for an object that fell from the lunar landing module a distance 80 meters to the surface of the moon. This figure shows the distance fallen versus time for an object. For an object, this is the distance fallen on y-axis. This is the time on x-axis, means t. From lunar landing, a module a distance 80 meters to the surface of the moon. Here we are going to estimate the slope of the secant PQ2. Here P value is, here the point P on x-axis 10, on y-axis 80. So here the point P value is 10, 80. And Q2, where is Q2? Here Q2 is there. So for Q2, here after 5, 6, 7, 8, 9 and 10. So at Q2, the x value is, yes, 7. On y-axis, this is 40 clearly. So at Q2, 7, 40. Here slope of secant PQ2. Here P value is, P is, what is P here? What is P? 10 comma 80, 10 comma 80. Q2 value is, what is Q2 value here? Yes, 7 comma 40, 7 comma 40. We know for finding the slope if 2 points are given, what is the formula for that? y2 minus y1 by x2 minus x1. Here this is x1 y1 and this is x2 y2. Assume. So y2 minus y1 means 40 minus 80 by x2 minus x1, 7 minus 10. So minus 40 by minus 3. So both are cancelled here. 40 by 3 is here 3 ones are 3 ones, 3 threes, point something. So 13 point something is there. Here 13 point something is the slope of the secant line, represent the slope of this secant line, or slope means here the rate of change of the secant line PQ2. Okay, this is the problem of fourth. Thank you very much for watching this video.